Okay, y'all, let's go ahead and start this process. This is very difficult, I think, but maybe it's more tedious than difficult. It's both. But once you get the hang of it, it's kind of fun. And the good news is like you're not gonna need this in the real world very often. Again, this is treadmill math. This is good practice. This gets you a lot of good skills. And I have used these skills before in my actual professional life when I was actually working in STEM, when I actually programmed and actually had to do like engineering programs and things like that. So I've worked on these before. I've implemented this before. With that said, I'm going to get started. How do I break this apart? Here it says the cube root. This is here. I'm going to go ahead and just do what I'm going to do. Are you ready? What I do to solve these is I break these things down. I'm supposed to say this number divided by this number for that. So 5 divided by 3. But for those who are typing it in, you'll know that what ends up happening is it's going to be a decimal number. So if you remember your old school division rules, right? What does this actually equal? Well, I can divide 3 into there one time. And then when I subtract it out, I'm going to have a remainder of 2. I'm going to have a remainder of 2. So it goes in one full time. And then I'm going to have a remainder of 2. And I'm going to show you a faster way to do it. But let me show you what I mean first. So I'm going to have that negative. That negative is actually a negative 1. That's what's sitting in front of there, times the cube root of x to the 5th. Now, you can do the division, and that's perfectly fine. And that works out if you know how to do the division, all right? That's great. So this is what I like to do. I'm going to break it apart like this. Negative 1 times cube root of x to the 3rd. Do you see that? Do you see how I broke this apart? I just matched the number. So I'm like, okay, 3 and 3. This sucker matches right here. Now, how many of those x's did I take away? I took away 2. So watch what I mean. This is kind of tricky. X squared. Now, if you can see this, if I had x cubed times x squared, it will actually give me x to the 5th. And if you don't remember, it's because of the rules of radicals, right? If I had x to the 1 times x to the 1, that gives me x squared. We're adding the radicals. If I had x to the squared times x to the 1, that gives me x cubed. It's because we're adding the radicals. So check it out. When I add these two, 3 and 2, when I add those, that's what gives me 5. But here's the fun part. This number 2 is smaller than 3. That means it's stuck. That means it's stuck. This can no longer simplify any more than that. It's done. It cannot come out. Now that this 3 and this 3 match, check out what happens. I can basically remove it out and bam, I have an x right there. And then my negative 1 comes down. Why? What's the cube root of x to the 3rd? Well, the cube root of x to the 3rd, let's see, x to the 1 times x to the 1 times x to the 1 is in fact x to the 3rd. So the cube root of x to the 3rd, the cube root of x to the 3rd is actually x to the 1. But we prefer to write it like this. And that's where this comes from. Get these numbers to match and put your leftovers over here. And I'll show you another example as well, although example 4 is a little easier. So with that said, I'm going to go ahead and put the rest of this together. I have a negative 1 and a negative, and with the x, and then I have my cube root left over with my x squared inside. And that's it. That's how you reduce these. So I'm going to load this up as a separate video because that was a lot of talking.